Hello, followers of my YouTube channels. Welcome to today's tutorial. I'm so late to upload a video. Sorry for that. And for today's section, we will see about the hydrological modeling using the hydrologic model called HEC HMS. We will see some tutorials, around 3 or 4 tutorials about HMS model. So before we are starting the softwares, it is better to know some highlights about the model, about the HMS model. And this HMS means Hydrological Engineering Center, Hydrologic Modeling System, it means. And it has hydrological component. The hydrological component here is, that means the hydrological cycle is represented by such a feature. It is almost similar to that of the SWOT model, what we have seen in the last tutorials. So there is a precipitation here, and there is evaporation from the lands. There is precipitation at the water bodies. Alright, and there is also groundwater flow here. Okay, there is impervious strata. That's almost similar, okay, with that of the SWOT model. And this HMS model is a numerical model that helps us to predict the runoff volume, peak flow, and timings of flow by simulating the behaviors of the watershed, channel, or reservoirs. Okay, it has a variety of modeling options in order to compute the unit hydrograph for basin areas, and also offers a variety of options for flood routing. Has different methods on the HMS, and capable of estimating parameters for calibrations of each basin based on comparisons of computer data to observer data. And when we see the advantages of this model, this HMS model, it can be applied to a variety of watersheds with different shapes, sizes, and characteristics. Graphical user interface makes the program user friendly, and the software is public domain. Okay, it is the main advantage that you can download this software from the HEC website, website without any cost. And it has some limitations, as you know that some models as a model, it has its own advantage and disadvantage. So the disadvantage or the limitations of this model is it's a deterministic model, and uncoupled model on evapotranspiration to that of filtration, and filtration to that of base flow, and no aquifer interactions. You see, we know that on the SWOT model, the hydrological cycle, on the hydrological cycle there is aquifer, recharge aquifer, charge and revap from the aquifer, like that. But here no aquifer interactions here, and constant parameter values are considered here. Okay, constant parameter values. You know, the values of the parameters are constant in this case. And dendritic system stream systems are considered, and also no downstream flow influence or rivers are okay. No downstream flow influence is considered under HMS models. And the applications of this HMS model is for urban flooding. You can conduct or use the model for urban flooding, flood frequency analysis, flood loss reductions, flood warning systems. You see, you can do flood warning systems, and reservoir designs, and other environmental studies. Okay, you can apply this model for those purposes. And HMS data management, and it stores the data on the HEC DSS. Similarly, It has automatic data handling. Okay, into conversions, interpolation, or accumulations are conducted here. You can read more about the software using the user manuals, and also it has its own main components. It has basin model components. It's a basins, reaches, reservoir, junctions, and the likes. Okay, and also the meteorological models like precipitation, potential vapor transpiration, snow melts. It has also control specifications. Okay, and also sub-basin infiltrations. It is loss rate method. If you see here, um, the control specification is time control during a simulation run. Okay, time control. We will see each things on the model, and also here is sub-basin infiltration loss rate method, like deficit constant, exponential, green amped, and graded SES curve method, SES curve number method, and the likes are here. And also surface runoff methods component is the surface runoff estimation using unit hydrograph like SCS, Clark, S-graph, Finder, the kinematic wave. Those are the methods. Those methods are available on the model, and you can select the best method for your runoff estimation, surface runoff estimations. The reaches, okay, for reaches you may conduct routing methods. For routing, you may have kinematic wave routing, lag time, modified plus, masking gum, and the likes. And also the reach, for the reach loss and gain methods, you can use constant or percolation methods are available. Alright, so those are the different components. It is better to read to get more knowledge about the model. And also there is simulation runs under the model, and there is continuous simulations here. Okay, so there is greedy simulation methods, and there is advanced reservoir features in the model. Okay, we can also do dam break evaluations here, and the likes. There is also parameter estimation methods. Alright, so to use the HEC-HMS model, you should have first delineate the watershed using the HEC-HMS model, and you can import or you can use data what you have delineated from HEC-HMS, HEC-GeoHMS to that of HEC-HMS model to study the it maybe has a surface runoff or the likes. Okay, so here is a website. This website what you are you can access the software. You can simply use this model, or go to your internet, and you can search like HEC-HMS Hydraulical Engineering Center. Okay, Hydraulic Engineering Center website, and you can download the software here. Different softwares. For our case, we need these HEC-HMS models and HEC-GeoHMS models. So the first software that you are required is HEC-GeoHMS to do a model on HEC-HMS. So you can download the model by clicking on this. Right, you can download here. So this is HEC-HMS, HEC-GeoHMS, and this one is HEC-HMS models. Okay, under software we can download those models from the HEC website. So if you have such information for the model, it is better to see introduction or the first parts of the model. Okay, So you should have to prepare a data for the model after you have installed the softwares, the HEC GeoHMS as well as the HEC HMS models. And those models are basically this HEC GeoHMS model is linked to that as the ArcGIS software. Okay, for instance, if you open this GIS software like this, so you should have an access on HEC HMS, HEC GeoHMS, HEC GeoHMS. Okay, you can open in such a way. Good, can open this HEC GeoHMS in such a way. So you should first install a compatible HEC GeoHMS model for your ArcSWAT, and after that you should have to prepare your datas. I would like to highlight the datas for this tutorial purpose. Those are the datas what we will use. Okay, so the first data needed for this HEC GeoHMS is the DM, the digital elevation model, and the second is curve number grid. That means you know about the curve number. This curve number depends on the land cover as well as the hydrological soil group on the watershed. So you should have a soil map and also land cover map. Using those land cover and soil maps, you can get a curve number grid by combining the two maps. Okay, and those are the data as well as outlets of your watershed are required for the HEC GeoHMS. And the next data are needed for the case of HEC HMS. So there is a step-by-step manual here for this tutorial. Hydrological modeling using HEC HMS, and to do hydrological modeling on HEC HMS, you should have to first do these HEC GeoHMS models, and after that you use output of this HEC HMS models to that of HEC HMS. So the first thing here is you can open a new MPT GIS software and activate if this HEC GeoHMS is not available here. You can check or uncheck this model in such a way. And after you have opening this, the first thing you should have to do is saving your MPT GIS software here or model, and I would like to save it. Where I would like to save is on the desktop, and I would like to create a new folder here, and its name is hydrological modeling using HEC HMS. Okay, you can say in such a way, and also here is you can change the name of the JS project, like you can say that HEC HMS modeling, HEC, this one is HEC GeoHMS and HEC GeoHMS and HEC HMS modeling. Good. So after that you can say save. So now the name of the GIS is now changed, and you can check that under the desktop there is one folder which is hydrological modeling using HEC HMS, and let me save it on the folder. Sorry. So we can see that on the folder we have this HEC GeoHMS and HEC HMS modeling project. So everything what we do here should be saved under this folder, okay, under this folder. So the first step here is pre-processing on terrain models, okay. So you should have to open a new map and you can save it, and also should have to check that ArcHydro tools and GeoHMS tools on the Arc toolbox. We can check that. Alright, you can check that on the Arc toolbox there should be ArcHydro tools and GeoHMS tools. Those are necessary to do different tasks on GeoHMS. And for my case, you can see that there is a tool which is ArcHydro tools here. It have different components, and also there is GeoHMS tools here. It has also different components. So we can do we have done our first tasks by creating our project in such a way, okay. So the second tasks here is pre-processing of our project setups. Here it has different components, the GeoHMS components, okay. Under pre-processing there is data management, memory conditioning, building wells, field seeing, flow direction, flow accumulation. We know that those things on GIS, okay, we should do those things. And the second is project setup. Here is we can start a new project and you can generate a project, and if you want to delete or remove the project, you can remove our project. There is also basin processing here. You can merge the basins here, and also can split basins, okay, in such a way. As well as there is some characteristics. If you would like to know the river length, river slope, basin slope, basin centroid, and as well as the centroid elevations, we can do everything under this, under characteristics. And also here is grid cells, the masking gam and kinematic wave parameters here, and also this curve number lag method, as we have seen on the theoretical part. You see, this curve number grid is necessary for that purpose. And finally we will import our models or create a HMS project, and this HMS project is necessary for our HMS models. Alright, so we will see those things, and there are different parameters also here. Alright, different parameters. You can add a project point, identify contributing areas, and there is reservoirs here, interactive flow paths. Alright, so we can get helps for HMS. So it is some introduction part of the HMS model, and for the next video we will see this pre-processing of these HMS models. It's now enough for today's tutorial. Have a nice time. Don't forget to share and subscribe the channel. Okay, so it's enough for today. Have a nice time. Bye.